All right, so the next part of law of sines that we call, this is going to be given, and this is example number 3. So with an example number 3, what we have is, this is an example of the side-side angle, or the ambiguous case of a triangle. We are told that triangle KLM has a measure of angle K equal to 82 degrees. And then we're going to have in two sides. Side M is going to equal 12, and side K is going to equal 15. So we're going to go ahead and start with angle K. And the reason this is called the ambiguous case is because angle K is 82 degrees here, but I don't know if this angle, the next angle that we're going to go ahead and find, and let's go ahead and call that M. I'm not sure if the triangle is going to be an acute triangle that looks like this, or the other possibility is that even with angle K here being 82 degrees, that angle M up top could be an obtuse angle that looks like this. So that's the question. So when we're figuring out angle M, we have to decide which of these kind of triangles. Sometimes it can be both, and you have two possible solutions for this. That's why the side-side angle case in specifically is a little bit more involved than the other ones. So let's go ahead and move this up out of the way, and we can go ahead and start to solve for that triangle. So we're going to start over here on the left-hand side. The other things that we know, we know that side M is 12 units long, and that side, we're going to put K over here, and this is angle KM and L. Side K is also, all right, and I'm also given that side K is equal to 15. All right, so then to go ahead and set this ratio up, I'm going to start with K. So what I have for here is 15 over the sine of 82 degrees is equal to 12 over the sine of, let me fix that real quick. So over the sine of angle M. That's the first part we're looking for, side of angle M. Now, when you go through and solve this, we're going to go ahead and multiply our ratio. When I do that, I get 15 times the sine of M is equal to 12 times the sine of 82 degrees. Divide both sides by 15. And now we're at the case we're looking for the sine of this particular angle. I leave all of this here. And I want to now use the sine, the inverse sine, because I need to find the angle. I just put all of this in my calculator this way. You can go ahead and get a decimal equivalent if you want, but when you go through and do that, make sure you do not round, because you can introduce some error when you go through and do that. Doing all of this, we find out that angle, and will give us the value of angle M. And that tells us that angle M is equal to 52.39 degrees, or rounding to the nearest tenth, 59.4 degrees. Now, remember what I said about that ambiguous case of the triangle? This is perfect for finding out this first triangle. Great. But what about the second triangle? Is that second triangle possible? So let's take it back and look back up what I have here. So is it possible that there exists another triangle here? How do I find that out? I take 180 degrees and subtract 52.4 from that. So is it possible that I have another triangle here that is equal to 128 degrees? And the answer in this case is no. Because if I look at these two triangles, that 82 plus 128, that is already greater than 180, and it means there's no room for the triangle. It's just not possible. All of the angles in a triangle have to equal 180 degrees, which was really nice because that means in this case of the triangle, I don't have to solve another one. This tells me right now this question only has one triangle as a solution. So all that means is I have to finish finding the triangle. So I know that angle M is equal to, take away this question mark now and make that angle equal to angle M is 52.4 degrees. I can now go through and based upon the fact that, make this a little bit smaller so I can fit it in on the screen. So I know that the fact that the measure of angle L is found by taking my 180 minus my original 82 degrees, and that was the measure of angle K, minus the measure of angle M that I just found, which was 52.4 degrees. So the measure of angle L is equal to 46 degrees. And I just rounded that to the nearest degree. You could also say that it was 45.6, depending upon how accurate you want that to be or how accurate I ask you for it. All right, so we are only finished. The only thing that we are left needing to find, we still need to find the length of L. We can do that now that we have found the measure of angle L. So to set the ratio up for that, I have that 15 is over the sine of 82. which is equal to L over the sine of 45.6. And if I do that, I get L is equal to approximately 11. And that's it for the ambiguous case of this triangle. There'll be other cases where if the second triangle is possible, you'll have to go through and find the other pieces for that triangle.